Hello, so good day everyone. Welcome back for another video discussion. This is ece23, Introduction to Digital Communication. This is yours truly, Ristar S. Arcabal of DS ECE3C. So, for today's discussion is all about SONET or Synchronous Optical Network. SONET uses a principle of TDM or Time Division Multiplexing. Is a method of transmitting and receiving independent signals over a common signal path by means of synchronized switches at each end of the transmission line, so that each signal appears on the line only a fraction of time in an alternating pattern. So SONET uses a principle of time division multiplexing. So basic of SONET, optical transmission interface, it was proposed by Bellcore Laboratories and was standardized by the American National Standard Institute. A compatible version, referred as synchronous digital hierarchy or SDH. The major design goals of SONET are: synchronous networks requires a single clock to handle the timing, synchronization, and equipment across the network. So it uses only a single clock to handle the timing and synchronization. There should be standardization of fiber optic transmission system equipment sold by different manufacturers. The physical specification and frame design must include mechanisms that will allow it to carry signals from incompatible tributary system. It is a multiplex transport mechanism and hence can be the carrier for broadband services such as ATM and DISDN. It is basically time division multiplexing system. So we have here the SONET structure. So we have here the STS to STS multiplexer, this one and this one. So a regenerator, also two regenerator, uh, and one add drop multiplexer. So STS multiplexer performs multiplexing of signals. It converts electrical signal to optical signal. STS demultiplexer performs demultiplexing of signals. Convert optical signal to electrical signal. Regenerator. It is a repeater that takes an optical signal and regenerates it. Add drop multiplexer. It allows to add signal coming from different sources into a given path or remove a signal. So we have here a section, portion of network connecting two neighboring devices. So it connects two neighboring devices. A line, portion of network connecting two neighboring multiplexers. So we have here multiplexers. A path, end-to-end portion of the network. So at this point, a path layer. It is responsible for the movement of signals from its optical source to its optical layer function. Line layer. It is responsible for the movement of signal across a physical line. STS mux and demux and add and drop multiplexer provides line layer function. Section layer. It is responsible for the movement of signal across a physical section. Each device of network provides a section layer function. So photonic layer. It corresponds to the physical layer of the OSI model. It includes physical specifications for the optical network. Network, optical fiber channel. Presence of light is equals to 1 and absence of light is equals to 0. So we have here advantages of SONET. Transmits data to large distances. So it can transmit data in large distances. Low electromagnetic interference, high data rates, and large bandwidth. So next, operation of SONET. The STS multiplexer and demultiplexer is used for two purposes. It multiplexes signals from various sources into an STS, or it demultiplexes an STS signal into various destination signals. The STL signals passes through a number of regenerators or repeaters while traveling from the source to destination. So it passes through a number of regenerators too and repeaters. The regenerators are basically repeaters and are bidirectional devices. They will regenerate the STS applied to them. This will eliminate any effect of additive noise on the quality of transmission. The SONET regenerators function at the data link layer. Add-drop multiplexer is capable of adding signals from various sources, or it can remove any signal and redirect demultiplexing the entire multiplexed signal. So SONET frame, this is a SONET frame. So it consists of 90 bytes and 9 rows. So the first 3 bytes of 9 rows is called the transport overhead. So it is also divided into section. First is the section overhead and the line overhead. Section overhead have 3 rows and line overhead have 6 rows. So the remaining bits or 87 bytes is called the information payload, and it is transported in a time period of 125 microseconds. So this is all about SONET frame. Consists of 90 bytes and 9 rows. First 3 rows is called the transport overhead. It is also divided into two section overhead and line overhead, and it is having a time period of 125 microseconds. SONET frame. It has a total of 3 cross 9 is equals to 27 bytes of administrative overhead. It has a total of 87 cross 9 is equals to 783 bytes of information. Administrative overhead is again bisected into 2 parts. First is the section overhead. 3 cross 3 is equals to 9 bytes. So it does framing, error monitoring, and management function. Line overhead, 3 cross 18 is equals to 18 bytes. It provides synchronization, multiplexing, and protection switching. Frame period is 125 microseconds. Data rate is equals to 8 bits times 9 rows times 87 bytes divided by frame period of 125 microseconds is equals to 50.122 Mbps. So we have here a SONET network ring. So we have here ADM or other drop multiplexer. So it has 2 rings. The outside ring is called the working ring, and the inner rings is called the protection rings. So the working rings deliver signal from ADM to another ADM. So if working rings fail, we have here the protection rings that reroute the signal from ADM to another ADM. So this is all about SONET network and SONET ring. It has working rings and protection rings. So SONET application. SONET can be used as carrier for ISDN and BISDN. It can be used as carrier for ADM cells, can be used for bandwidth on demand, and can be used for cable TV networks, and also can be used for T1 and T3 carrier lines. So that's all for our video discussion. I hope you have learned something, and thank you.